Hello students, in previous lecture we were solving numerical problems. In that continuation, let us discuss some more questions. Come to this question. A stone is allowed to fall from a top of a tower 100 meter high. At the same time, another stone is projected vertically upward from the ground with a velocity of 25 meter per second. Calculate when and where the two stones will meet. What you have to find out and what is given, let us see. One stone is here at the top of the tower and one stone is projected from the ground. The height of the tower is 100 meter. And this is the stone first, suppose karo. And this is the stone second. Assume the stone first travel the distance x and the stone second also travel the distance. What is left? 100 minus x. And here they met. On this basis only you can solve the problem. Now let us see how we will solve after this. For stone 1. Stone 1 is allowed to fall from the top of the tower. Means the initial velocity of the stone is 0. And nothing more is given there about the stone 1. So the distance travelled by the stone 1 will be ut plus half gt square. Here the value of g is taken 10 meter per second square and it will be positive. And this is equal to 0 into t plus half 10 t square, and the distance travelled by the stone 1 is x. So we will leave with x is equal to 5 t square. Now for stone 2. For second stone, the initial velocity given in the question is 25 meter per second. And the distance travelled from here we will write 100 minus x. Therefore, from this equation, 100 minus x is equal to 25 into t minus half 10 into t square. 10 value of acceleration due to gravity, that is the 10 meter per second square. Here the stone is going in upward direction, so the negative sign of the g is taken here. Now put the value from equation 1. This is the equation 1, suppose. Now we will put the value of x from equation 1. 100 minus 5t square is equal to 25t minus 5t square. This will be minus 5t square will come here. Now this and this term can be cancelled and we will leave with t is equal to 100 by 25 and that is equal to 4 seconds. Now where they will meet? We will put the value of t in equation 1. Now x is equal to 5 into 4 into 4. That is 80 meter. And from the ground it will be 20 meter. 100 minus x will be 20. Thus the stone will meet 20 meter above the ground. Both both stone, hence both stones will meet 20 meter above the ground. Stone 2. For second stone, the initial velocity given in the question is 25 meter per second. And the distance traveled from here we will write 100 minus x. Therefore, from this equation, 100 minus x is equal to 25 into t minus half 10 into t square. 10 value of acceleration due to gravity, that is the 10 meter per second square. Here the stone is going in upward direction, so the negative sign of the g is taken here. Now put the value from equation 1. This is the equation 1, suppose. Now we will put the value of x from equation 1. 100 minus 5t square is equal to 25t minus 5t square. This will be minus 5t square will come here. Now this and this term can be cancelled and we will leave with t is equal to 100 by 25 and that is equal to 4 seconds. Now where they will meet? We will put the value of t in equation 1. Now x is equal to 5 into 4 into 4. That is 80 meter. And from the ground it will be 20 meter. 100 minus x will be 20. Thus the stone will meet 20 meter above the ground. Both stone, hence both stones will meet 20 meter above the ground. Final velocity is 0 as the stone is attaining its maximum height. Time is not given. Acceleration is given 10 meter per second square in downward direction. When the stone will go in upward direction, in that case the value of this g will be minus, that is negative. Now we are having u, v and g and we have to find out the displacement, that is the maximum height we have to find out. And now I think you will say the formula v square minus u square is equal to 2gh will be used. Now put the values. 0 square minus 5 square is equal to 2 minus 10 into height maximum. We can write this as minus 5 into 5 is equal to minus 2 into 10 into height maximum. These two negative signs will be cancelled out. Then we will leave with height maximum is equal to 5 into 5 by 2 into 10 to 5 by 4 and this is equal to 1.25 meter. Now we have to find out the time taken to complete the journey. Means the stone will achieve the maximum height and the stone will come back. Two time we will find out separately, then we will add it. Let us assume the time taken by the stone to reach the maximum height is t1. In this case, the initial velocity of the stone is 5 meter per second. The acceleration is minus 10 meter per second square. We have taken the negative sign as the motion of the stone is in upward direction and acceleration is acting in downward direction. When the acceleration is in opposite direction of the direction of motion, then we will take negative acceleration. Now final velocity is 0 as the stone achieved the maximum height. Now we will use this formula V is equal to U plus GT to find out the time taken to attain the maximum height. And now put the values. 0 is equal to 5 minus 10 T1 and T1 is equal to 5 by 10. This implies 0.5 second. 1. Now T2. T2 is the time taken by the stone to come back to the ground. In this case, to find out the T2, the initial velocity is 0. Why? Because at maximum height, the velocity of the stone is 0. And acceleration due to gravity or the acceleration given in this question will be 10 meter per second square. Positive acceleration we will take because the direction of motion and direction of acceleration is same. Now we will find out the value of T2 and we also know the height of the object, that is equal to 1.25 meter. And this height is the displacement here. 1.25 is equal to U into T2 plus half 10 into T2 square. Here the initial velocity we will take 0. T2 square is equal to 1.25 into 2 by 10. We can write it as 125 into 2 by 10 into 100. Now cancel this. This is 5 and 25 5 ja and 25 4 ja. Now this is equal to, when we will cancel this, we will get 5 here and this is 1. Now we can write it. This will be also cancelled out. We will leave it. T2 square is equal to 1 by 4 and T2 is equal to root under 1 by 4 and this is equal to 1 by 2 and this implies 0.5 second. The total time of the journey will be T1 plus T2 is equal to 0.5 plus 0.5 is equal to 1 second. Let us come to this question. Obtain relation for distance travelled by an object moving with uniform acceleration in the interval between 4th and 5th second. Means if the object is moving on this path and that object covered this distance in 4 seconds and this distance in 5 seconds, then the distance traveled between 5th second and 4th second will be what? Distance traveled in 5 seconds minus distance traveled in 4 seconds. This will be the distance traveled by the object between 4th second and 5th second. Okay, so we will find out separately S4 and S5 first, and after subtracting we will get the result. Distance traveled in 4 seconds. Here the time is 4 seconds and acceleration is uniform. So you will take A, only A. This is U into 4 plus half A 4 square, 16. And this is equal to 4U plus cancel 8A. This is S4. Now S5. Here the time will be 5 seconds. U into 5 plus half A 25. And this is equal to 5U plus 25 by 2A. Now S5 minus S4. This is equal to 5U plus 25 by 2A minus 4U plus 8A. Now S is equal to 5U minus 4U plus in bracket 25 by 2 minus 8 into A. This is equal to U only, and after calculating this we will get 9A by 2. This is the distance travelled between the 5th second and 4th second. Let us come to this question. I hope this will be the second last question. Let us see. 2 stones are thrown vertically upwards simultaneously with their initial velocities U1 and U2. Prove that the height reached by them, means maximum height reached by them will be in the ratio of U1 square by U2 square. Okay, now let us find out the height achieved by stone 1, and in that case what are given in the question. For stone 1, the initial velocity is U1, the final velocity is 0, as the stone achieved the maximum height, and acceleration is minus g because the acceleration is acting in downward direction and the stones are thrown vertically upward. Now we will use the formula v square, suppose minus u square is equal to 2as, 0 square minus u1 square is equal to minus 2gh1. h1 is the height attained by the stone, and from here h1 is equal to u1 square by 2g. These two negative signs has been cancelled out. Now for stone 2. The initial velocity for stone 2 is u2. Final velocity will be 0 because this stone also achieved the maximum height. Acceleration in this case also will be minus g because the acceleration is acting in downward direction and motion is in upward direction. They are opposite to each other, therefore the acceleration will be negative. Now the formula used will be v square minus u square is equal to 2as 0 square, putting the value, minus u2 square is equal to minus 2gh2. Here h2 is the height, maximum height attained by the stone 2, and from here h2 is equal to u2 square by 2g. If this is equation number 1 and this is equation number 2, then by dividing equation number 1 by equation number 2, we have h1 by h2 is equal to u1 square by 2g into 2g by u2 square. This cancelled out. Then the ratio of height will be in the ratio of u1 square by u2 square root. Now come to the last question. Here the question is an object starting from rest and travels 20 meter in first 2 seconds and 160 meter in next 4 seconds. What will be the velocity after 7 seconds from the start? And let us look how the journey of the object is going on. The object starts from rest and it goes from rest to here and it covers 20 meter in 2 seconds. Again from 2 seconds to 4 seconds it covers 160 meter, and after some distance travel you have to find out the velocity of the object. And to find out the final velocity of the object within this situation we need u plus at. Neither the initial velocity from here is known nor the acceleration at this point is known. So we have to see the situations given in the question, and from there we will get information that will help us to find out the value of velocity of the object after 7 seconds. So let us analyze the journey of the object first. Now see, in first duration, that is from 2 seconds, body is starting from rest. So the initial velocity will be 0. Distance covered is 20 meter and time taken is 2 seconds. With help of this information, only we can find out the acceleration. So we will take help of this formula. S is equal to ut plus half at square. U is 0 into 2 plus half into acceleration we are not knowing, and time is 2 into 2, 4. Distance travel is 20. And from here acceleration is equal to 20 into 20 by 4, and this is 5, and this implies that acceleration during this period is 10 meter per second square. Now let us see what is the position of acceleration during this period, during the 4 seconds. And for this we need initial velocity after 2 seconds. And final velocity we are not knowing, and time is given and distance travel is given. So to find out acceleration during this period, we need initial velocity that we can find out from this information. Then final velocity after 2 seconds is v is equal to u plus at. U is 0, a is 10, and time taken is 2. So the final velocity will be 20 meter per second. Now for next 4 seconds, the distance traveled is 160 meter. Initial velocity is 20. Time taken is 4 plus half acceleration we have to find out. Suppose in this case acceleration is a1 and the time is 4 seconds, so 16 will come here. In this case a1 will be equal to 160 minus 80 into 2 by 16. 80 into 2 by 16, and this is equal to 5 10 meter per second square. Now what we observe, during from starting point to end of the 4 seconds, the acceleration is same. This is the 10 meter per second square, and here also 10 meter per second square. So we can use the simple formula v is equal to u plus at, because when we use this formula, only we can use this formula when the acceleration is constant. And what we observe, during from starting to end of the 4 seconds, the acceleration of the object is 10 meter per second square. So we will put the initial velocity 0, acceleration 10, and time 7. Therefore the final velocity after 7 seconds is 70 meter per second. Now let us see what is the position of acceleration during this period, during the 4 seconds. And for this we need initial velocity after 2 seconds, and final velocity we are not knowing, and time is given and distance travel is given. So to find out acceleration during this period, we need initial velocity that we can find out from this information. Then final velocity after 2 seconds is v is equal to u plus at. U is 0, a is 10, and time taken is 2. So the final velocity will be 20 meter per second. Now for next 4 seconds, the distance traveled is 160 meter. Initial velocity is 20. Time taken is 4 plus half acceleration we have to find out. Suppose in this case acceleration is a1 and the time is 4 seconds, so 16 will come here. In this case a1 will be equal to 160 minus 80 into 2 by 60. 80 into 2 by 16, and this is equal to 5 10 meter per second square. Now what we observe? During from starting point to end of the 4 second, the acceleration is same. This is the 10 meter per second square, and here also 10 meter per second square. So we can use the simple formula v is equal to u plus 80, because when we use this formula, only we can use this formula when the acceleration is constant. And what we observe, during from starting to end of the 4 second, the acceleration of the object is 10 meter per second square. So we will put the initial velocity 0, acceleration 10, and time 7. Therefore, the final velocity after 7 seconds is 70 meter per second. Let us discuss next question. This question is, a stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in downward direction, when the stone is going in upward direction, if the acceleration of the stone during the motion is 10 meter per second square in downward direction, the acceleration is always in the downward direction. What will be the height attained by the stone, and how much time will it take to reach the ground? Okay, so the direction of acceleration is always in the downward direction. This is the G we represent here, and the stone is thrown from the ground. It will go to a maximum height, and this height you have to find out, and also you have to find out the time taken by the stone to achieve the height and come back to the ground. Okay, so first find out the maximum height attained by the stone, and for this you see at maximum height the velocity of the stone become 0. So initial velocity is given here 5 meter per second, final velocity will be 0, acceleration is also given, and we have to find out the distance, height. So we will use which formula? Let us see how we will decide. The initial velocity given u is equal to 5 meter per second, v